Today we have Mrs. Meghna Muralidharan. She is the AI conversational engineer in Google. Another one is Mr. Anish Kumar. He is the AI software engineering manager for Asia Pacific in Intel. So fortunately, Mr. Anish Kumar registered for PhD in the department of ECE. He is working in the area of Triple E is working in the area of application of AI for electric vehicles. Similarly, Ms. Meghna Muralidharan is going to join as a PhD scholar in the department of ECE. She wants to apply this conversational AI for electric vehicle, like your Alexa. Alexa, what do you do with Alexa? You can start or stop or whatever it may be. Similar type of technique is possible for electric vehicle and all that she wants to work. Means by sitting in the vehicle itself, she can give the command straight away so that the vehicle will start or stop or something else. So nowadays, AI is integrating in all the fields of engineering. Need not be only computer science engineering. Actually, AI is one of the tools used for solving all sorts of engineering problems. So they are here to solve some problems relating to both Triple E and ECE. So it's a fortunate for us to have the speakers from world-renowned companies like Intel and Google. So I'm requesting all of you, please give a big round of applause to these guest speakers. Probably they will talk about this conversational AI and generated AI for all of you. After their presentation, you can pose as many questions as possible because they are the people who are really working for solving the problems in industry. So this is the wonderful opportunity for all of you. Utilize this time properly and try to pose as many questions as possible and get the answers. Madam, you can start.
Positive note, we are able to solve this issue. So the good part is I'll be able to even show the demo in Google Cloud Console. Okay, so let me introduce now that we have the content up and ready. Has any one of you, I think most of you are students, have you heard about the conversational AI, and can you think of ideas where you can apply conversational AI in electronics or electrical or anything to do with mechanical, right? Any other field, like what I'm talking about is an interdisciplinary amalgamation of two technologies, right? One is conversational AI. AI is a software stack, and then you have the electronics, right, which is embedded, anything to do with hardware or wireless or electric. Can someone from the audience able to first give a gist of what conversational AI could be? Anyone? What do you guess what I'm able to talk in the next half an hour or a couple of minutes? Anybody? Okay, I think I can get started. So of late, in the past 1 or 2 years, you must have heard about conversational AI, generative AI, ChatGPT, right? And some of you may have even used these technologies for your day-to-day needs, like researching on some topics, generating content, modifying email, right? You may have put some content and you want to modify it, right? But what that is about is generative AI, wherein you give some prompt, we call that sentence that you give as prompt, and then you generate content out of it. That is called as generative AI. Now, what is this conversational AI about, right? So these are the two main topics that we are covering for the day. Conversational AI will be taken up by me and generative AI will be taken up by Anish. But before that, I want to explain that, conversational and generative AI, though they are mutually exclusive, but there are similarities. So conversational AI is a field of AI that will, that basically understands the conversation between a user and computer through natural language. When I say natural language, like computer understands the context of what the user says and try to give a follow-up response. The computer or the bot tries to give up a follow-up response. So the examples are like the Siri or the Google Assistant. You say, hey Google, what is the weather, right? Or hey Siri, can you help me, identify the next destination, something of your choice. So that is about the conversational AI. Now, generative AI is something to do with generating content with regard to, it can be a multimodal content. When I say multimodal, it can be generating text or generating audio, generating video, right? So all these are part of the generative AI. And the both are being trained on a common data set. Now, before I go further deep into the topic, I think I forgot to introduce myself. So, as Sir said, my name is Meghna, and I've got 16 years of corporate experience. So, just like you all, I graduated from electronics and communication engineering 16 years ago. And then I started my career in embedded automotive domain. I was working in Robert Bosch for a few years. And I was working on engine control units and hardware and the diagnostic protocols. And over the years, I took transition to software. So I am a person who can very well understand what is electronics, but on the other side, what is AI. And now my research topic is going to be like, how I can marry these two topics. One is AI and one is electronics, right? So now you may ask me, okay, I'm studying electronic, I'm studying electrical wireless. Now how is this relevant for me, right? So you can think of a lot of applications. I'll tell about the use cases and applications in a while. I have some slides for that, wherein you'll be able to relate, okay, conversation AI can be applied to my field. This is how it can be used. I'll come to that point. Okay. Okay, so this is the agenda for the next half an hour. My session is going to be for half an hour. I'll not take a lot of time. So I'll talk about conversation design in general. And then once I just cover fundamentals in a few minutes, I will show a demonstration about conversational AI in Google Cloud, right? Do you all know the cloud providers? What are the various cloud providers available, public cloud providers in the market? Do you know? Anyone? Azure, AWS, right? Amazon Web Service and Google Cloud, and there are many other, IBM Watson, and there are many others, right? So conversational AI as a technology is available in all these cloud service providers, but since I am working in Google Cloud as a conversational AI consultant, I'll be able to demo how you can kind of build very interesting chatbots in Google Cloud Console. So I'll be having a demo, and then I'll be able to relate some of your use cases with conversational AI in electronics or manufacturing industries that that you'll be able to think about in later time. Okay, next slide. So before we talk about conversational AI, as I said, it's a field of artificial intelligence. And what a conversational AI primarily does is it will basically train on the data. Data here in the sense is what the user says. When I say, hey Google, when I talk to the Google Assistant, hey Google, what is the weather today, right? Now even I can say that, okay Google, how is the weather forecast going to be looking like tomorrow? See, I have modified the sentence, right? But if you were to design such a chatbot in a very traditional manner, you imagine you have to kind of put all these conditions, right, metrics of conditions, and feed into the system. So that will become a very hard-coded system, wherein you have to feed in the user utterances, what all sentences I can talk and what the bot will or the computer will respond to based on my user utterance, right? And that becomes very difficult, correct? And that is where, to overcome that, all the in AI you can use a multiple models. Google Cloud uses something called as a Gemini 1.4 Pro, and you can use all these models to understand the natural language, and this is what is called as NLU, or the natural language understanding, to get the context of what the user says without hard coding, right? Even if I say, hey Google, what is the weather, or how is the weather going to be looking like, or any other variations in the sentence I make, the model will understand that because it has been trained on that sentence, and gives the response. So there is a very famous conversational previous slide. I'll just quote that what he says. Conversation design lead at Google, who says, a conversation design has to be a carefully curated back and forth between human and artificial AI machine, right? And that is precisely what you see in Google Assistants and Siri or Alexa. Okay, so when you are designing a conversation system for let me take the example of say a manufacturing industry, right? Okay, if I'm going to industry specific, please cut me short and be candid to tell me that you cannot understand. I'll be open to making variations to how I am giving my lecture. Okay, but this is a very this is an example of a conversation where it involves B, the ones in highlighted is the bot, and C is the customer, right? Then suppose the bot says, and suppose you're working for a wireless company, okay? Hey, thanks for calling XYZ Wireless. This call may be recorded. For your convenience, now we have options to quickly assist. And then the bot says a lot of, verbiage. And then the customer says, hey, I want to, please enter your account PIN followed by £. So the customer says, customer service. Now, can you give me a little more details so that I can get you to the right person, right? So as you can see, the customer is like giving very, very short and succinct words, but the bot is giving a very detailed, detailed response to basically what the user utters, right? Which is the customer, what the customer utters. So these kind of applications are seen in multiple industry verticals. One is like, this is an example of a telco, but you can think of it in manufacturing. Suppose you have some, product troubleshooting, and then through conversations you can kind of, understand the troubleshooting mechanisms, going back and forth between the product, which is like the machine, and between the user, right? So, and this has been done primarily through the NLU model, and in next slide. No, I think it's not come up fully. Okay. So, so suppose you say through the I want to eat some bananas, or in the previous example you say I want to do a customer service, right? And then the bot says how many of them. Next slide, I think. Yeah, that's it. So no, previous slide. Yeah, here. So so when what is primarily happening is when the user says, gives a context, I want to eat some bananas, and then there is an intention behind it. So the natural language understanding part of this thing is say that it is trying to eat something. So the intent is eating something, in this case eating bananas. And what is the entity or the, the kind of, the adjective associated with it? It is a banana. So the entire, in Google Cloud or in any other cloud service platform, the entire, the technological stack involving modern conversational design is involving intent and entities. So when a user utters, intention, or in technical terms, intent of the conversation is extracted, and then based on that, the bot replies saying like how many of them, how many bananas, right? So this is the modern chatbot concepts. So what I'm essentially trying to say is you're not hard coding anything. All that you're giving is just giving to the model the various permutation combinations of what the user may utter pertaining to that use case, in this case eating something, and the model will capture all the training phrases associated with that. So I can say like I want to eat some bananas, I want to eat more bananas, eat bananas. So I give all that combinations in the system, right? Now you may be asking what is that system? So the system here is in Google Cloud, there's a tool called as the Dialogflow. So Dialogflow is the tool or the technology stack that we use for building such chatbots. So I'll be demoing shortly to you how we build very basic chatbots. There are a lot of open source chatbots also available called as the Rasa AI. You can explore it yourself. But in idea, the entire essence is the modern chatbot designing involves user utterances, capturing the intent of those user utterances, and then the bot replying as per that. So you don't have to do anything. All that you're doing is using an NLU model or the natural language understanding AI model to train on the data set. In this, the data set are the human dialogues, and generating the responses based on that, right? Now, this is slightly different from generative AI technologies or the chat GPT kind of technologies, where you're using neural network to train whole bunch of more data sets. It's not just the human dialogues, but in this case, you are just, so there is a lot of similarity between how you use these kind of chatbots versus how you use chat GPT and related technologies to generate responses. Because as you see, chat GPT is also like a conversational AI, but more than conversational AI, it is also generating content for you. Yeah, sure. Next slide. So let me, I think enough of, all this lecture, and let me go into the console and see so that it becomes more interesting for you. So yeah, just before that, one more last slide on how the natural conversation learns from the past exchanges, right? So with an NLU model, which is part of the AI model, in this case, in Google Cloud, we use something called as Gemini 1.5 Pro. You remember the details of the conversation based on the context, and based on that, you kind of, continue the conversation so that it looks more natural. And this applies to not just a chatbot, but it also applies to the voice bot. Like if you have a speech, and that speech has to be converted to text, so you have something like the speech to text, right? Or if you already have a text which is in a text script, and then you want to convert that to a speech, then you have a text to speech. So all these functionalities are there in the inbuilt system. And okay, now let me just explain what are the typically challenges we hear from a lot of our customers. Okay. So when we tell a customer, like from a manufacturing vertical or electronics vertical or electrical vertical, right? So they say that see, we run into a lot of challenges, and one is, like we don't have say data. It is difficult for us to retrieve the data because our data is all fragmented. It is not in one system. It is in multiple such places, and we want to all consolidate that into one common system. So that is one challenge that we hear from our various customers. And then they say that, hey, we want AI in our manufacturing plants, or places where there are electrical systems running. But then we are actually kind of crippled, as in we don't know how to use it, where to use it, right? So how do we inculcate AI into our existing traditional system of manufacturing? So this is another thing. Then comes the infrastructure security. You know that, when we speak about manufacturing sectors or highly regulated systems, there is a big issue with regard to the security, because these are all highly secure systems. Connected through cables. The data has to lie. The data which is generated from these machineries or the system should be there on the premises, and they don't want it to be going into a public cloud, right? Like AWS, Azure, or Google Cloud. So how do you ensure that we are having a secure infrastructure? And then omnichannels, they say that, hey, we have many other systems, like we have CRM system integrated, ERP system integrated, and we want those also to be integrated to our conversational AI experience, because we are getting data from there also, right? So now all these problems that we hear from the customer can be solved using Google Cloud technology. Okay, so any questions from anyone? I think we have to make this session more interactive. So this is the Google Cloud console, and see, whatever I am talking about, these are all, so anything, have you all used any, did you all get chance to use any of the public cloud service provider, like AWS, Azure? Anyone did get a chance? Have you been working, anyone? No? Sorry?
That we are using for customization of our application.
Okay. Oh, that's great. So I think you're all not new to these things, but let me just show you a glimpse of how Google Cloud looks like. So we have a variety of these services, but now since we are like infrastructure, security, computing, and then like if I see all products, I'll get anything to do with analytics, AI, application development, artificial intelligence, everything. So all these are there in the console. And then for this purpose, I use in Google Cloud, there's something called as a Vertex AI. So this Vertex AI is that unified tool which gives, it's a one platform where you have any ML tools, like it has the foundational models and it has out of the box solutions also. So what we are going to use is Vertex AI it's called as Agent Builder, which is a platform for searching, recommendation and conversation labs. So I click here. In the meantime, I open, there is, as part of the conversational AI spectrum, there is another tool called as the Dialogflow. As you can see, this is Google Cloud Console is different and Dialogflow CX Console is also slightly different. So I would have already created a project. So these are two separate consoles. So if you want to build basically a chatbot kind of an application, then you have to go to, the Dialogflow console, CX console. So I'll click here. It is linked to the same Google Cloud project, and I have all these applications that I have that are built, right? So now suppose I select one of it, and what I'm selecting here is an agent, right? So agent is nothing but a chatbot. Think it of as a chatbot. So whenever you want to keep building a new chatbot, you'll keep building a new agent. So so this is just like, it is like a kind of a no-brainer. All that you have to do is just try building your conversation flow by just dragging, drop, or just building like a flow chart, like how you'd build a flow chart, right? So it's just like that. And so I already have something. Suppose you're trying to build an application for some system. So suppose you're working for a wireless company, right? And XYZ wireless company, and you want to build some kind of a system wherein you do a billing and payment, and wherein you want to debug or troubleshoot the wireless products, right? So I kind of build this chatbot, and then I've already built one. And I was talking about the intents, like when you tell a conversation, how the agent kind of picks up, right? So here these are the intents. So suppose I want to say, hey, I want to view my bill. So I give a variety of combinations for viewing my bill. So I give various permutation combinations of the phrases that is used for viewing my bill. So because I may say view my bill, or I may say, hey, I want to view bill, or I want to view the bill, right? So you give various of permutation combination of the training phrases, but eventually the natural language NLU model will understand what is the training phrase about, and understand what is a view bill. Okay, now let me quickly test. So I say test agent, and then they say hi. So when you say, so good day, what can I do it for you? Hope you can see my screen, right? What can I do it for you? So I say view my bill. So when I say view my bill, so then the bot has responded. I want to be able to view the bill, and I was able to make the payment for 1 month. So all this response that you have see here, because I have kind of hard coded that in my bot. Okay, but going forward, how the technology is shaping out to be is, you don't have to literally hard code everything, because in conversational AI, you can also be able to you'll be also be able to generate responses. Like suppose you have a PDF document about some some manual, electrical manual, and then if you upload it, you can generate the summarized version of that document. So what I do is I just go here, and then suppose I've come to billing and payment, and after billing and payment I say, hey, I have an internet issue. So I go to internet issue, and then I link something called as, so I upload this document. This unstructured document is nothing but a PDF document about internet issue. And then when I say internet issue, it will basically go to that document, summarize all the information for me, and generate the response. So here what I am showing is, it's a combination of what I have hard coded together with what is generated, which is nothing but a generative technology, right? And this is how the conversation will look more and more natural and human-like as we go forth. Okay, so any questions here? Any questions, any doubt? Have you come across some bots? Or is bot building part of your curriculum? Just curious. No. Okay. Okay. So that's okay. And yeah. Now going back, so some of the use cases that we see commonly in in pertaining to manufacturing is like, one is a customer service automation. So suppose you have some kind of a troubleshoot a particular part of a machinery, and then you say the equipment A, I have been notified of a diagnostic fault. Do you wish troubleshooting now? Right? Now this is what the bot says. Now the customer say, what does the error code relate to? An error code relates to insufficient voltage supplied by the memory backup battery, right? So can you relate to how you can build chatbots for customer service automation, correct? In nutshell, when you say customer service, you just don't think about like, Hey Siri or Hey Google kind of application. You can actually build applications or bots at the manufacturing line and use it for troubleshooting products or ordering some kind of a replacement parts or some kind of scheduling the service. And how you can build it, like within the Google Cloud, like if you want to take Google Cloud as an example, within the Google Cloud, you can go to Dialogflow console that I showed you some time ago. Start with like basically building some kind of a flow. Start with hard-coded responses. You can upload some manuals that you may be having, generate responses, and then build a more human-like conversation and deploy it. So these things can be, can be built very easily, even with limited to no programming language. So what I want to highlight is like, there is always a misconception that AI or generative AI needs a lot of, programming skills. Of course, you do need. With Python, yes, Python is a go-to language for programming, and there are a lot of scripts also. But it is not becoming the norm. What we are seeing in the industry is that even with limited or no code background, you can kind of build these applications, AI applications, and you can also choose career lines even without the programming language background. You can have, because I too come from an electronic background, right, where we don't give a lot of emphasis on hard code programming, unlike computer science. But then what the foundation knowledge that we need is the basics of AI, like what are the models, what are supervised models, unsupervised models, foundation knowledge of machine learning, and then you can kind of start building this conversation. So conversational AI as a field is the lowest, lowermost in the stack of AI, where you require minimal to low coding skills to build all these kind of applications. So the next, the other application that we again see and which you will be able to generally relate to is like the document searching and synthesis. Suppose you have like large, long manuals, like a very lengthy manuals and technical specification document, where you want to get a summarized version of, say, exterior locking door handle. I want to get the summary of exterior locking door handle for the years 2000 to 2023, right? So if you want this kind of information from from your documents, all you have to do is like upload the document, and yeah, so this is a place where you kind of upload the document. So I've gone to Agent Builder, and see here I've developed this data store. So data store is nothing but a place where you upload the documents. So I go to data store, and then I have something called as an unstructured document, and if I just click here, and this is where I have uploaded my internet issue related document. So this is nothing but a PDF. Unstructured data means it's just a PDF. And then when you click on this internet issue document, you see anything to do with it. So how you can relate it is you can upload your manuals here, and you can kind of link it to the chatbot that you have created and get the summarized version of summarized version of what you're looking for, right? So yeah, so this is what I was talking about, the document search and synthesis. So manufacturers can retain many generations of document throughout the product life cycle pertaining to design, supply chain, manufacturing and service, and you can use them to generate new content and needed for your business function. Right. So this is all I had to share with Foundation, but I'll be open to taking up some more questions. Do you have any questions? Like Nothing to do with conversational AI in general, but are you curious about anything more, like how do you want to get into industry? I'll be happy to answer now. Any questions, anyone? Nothing to, don't get bogged down by conversational AI. Conversational AI was just a topic today I chose because that's the area that I work in. But do you as students have any questions? Are you curious about cloud service, cloud like Azure, AWS, Google Cloud, anything in technology, any industry, any area that you might be interested in? Anybody from the audience? Was my lecture so boring or so technical? Something is wrong. Anybody? Let's be let's have an open conversation from the students. Yeah, I think. Shall I do that? I don't want to put you on spot. Ma'am, do you have any questions?
We are having bots in AWS, I think.
Okay.
That directly, instead of you are integrating two things. One is you are giving data, another. It is like a encoder decoder mechanism. It is working here.
Yes, transform.
But in some other cloud, I thought it was AWS. Directly, bot is there. Bot app is there. Once we choose the bot app, automatically it is it itself doing both the parts. Is it possible here also?
Yes. So what I showed you is it's a combination. So as you said, you can give the hard code the responses. So I'll tell you where it will come into application. So there may be like highly regulated industries where you want to have hard coded response, like suppose medical or healthcare or you know, even some manufacturing, I think, use cases where you want to definitely have hard coded. That is where you give hard coded response. And then you want to have generated also. Generated means it will be little more casual, right? It will be summarized version, and accuracy of that generated data is not guaranteed in that case for generative, because generative AI or generated data is a evolving thing. So when you go for a combination of both hard coded as well as generative, that is when you are able to utilize a full spectrum of the application.
That means this is the more optimized method rather than the using bot directly.
No, bot is the agent. Agent is a bot wherein you can hard code the response. So in the bot itself, you can say that you are forcefully telling the response. Like the bot will only give this response to what is my weather, right? So that is one way. But then if you want the bot to just give a casual response, hey, I think the weather looks bright and sunny. That also you can do. So you can do both these things in one single agent or one single bot. So that is what we've seen in most customers also. They don't want to go only for generative, because only generative means the content will not be accurate. And only hard coded means it will look very robotic, right? Hey, how is the weather? 20 degree. How is it sunny? Like whatever we give as a response. So we see a combination. And with any cloud service provider, it will be a combinational approach which will be work. So not just be AWS, but with Google Cloud also. Anything, yeah.
How much pre-services are existing in Google?
Sorry?
Here there are many free services.
Yeah.
I have seen in some other cloud. Here also, do we have free services?
Yeah, I mean, so typically I think I'll have to check on that and get back. Typically these are all paid products, right? Paid services. But for students and for academia, probably there are some free credits which the Google Cloud is providing. But probably I'll have to check that and revert. Yeah, I know that these are all like, since public cloud providers means all. But then there are also freely open training sources available, training materials available, called as a Cloud Skill Boost. Let me just look into the link, and before I wind up, probably I'll be able to share. It's for students and it is completely free. You can learn all these AI technologies at your pace. It's like a lab. Though you will not have access to the cloud credentials like how I do, but for learning purposes, you will have access for a limited period of time for learning. And once you complete that course, you'll get the certificate or the badge. And then you can, but then actual credits you can apply only to the cloud console, which you may not be having currently. Yeah.
Thank you.
Any last question? I think I'm running out of time. So next topic will be generative AI. Before that, any more question from the students? Any curious students here? Okay. Okay, then I will. So my session for today is wound up, and I'll hand over to Anish, who will be taking session on generative AI technologies. Yeah.
So good afternoon, everyone. I think thanks for coming here for this exciting workshop. And many of you I know are from non-computer science background, mostly from electronics or electrical background. And you might be thinking this generative AI or this AI is not my area of domain. Probably it's not interesting for me. But I'll try to change your assumptions of that and see how generative AI can be your best friend or can be your worst enemy. Right? And so today we'll talk about the introduction and give you some of the challenges and then what are the opportunities generative AI can give you. So before that, some standard notices and disclaimer. Okay, I'll introduce myself, right? So I am a computer science engineer, right? Basically I did my BE in computer science, and even though my background is computer science, I have been extensively working on a lot of electronics and electrical things. Some of the things back in 2014, I built a 3D printed drone. This entire drone was completely 3D printed, and we got the open source electrical items that can actually be programmed, and we can actually build a completely drone. This is almost a 6 feet hexacopter that we built, and I have built a robotic arm and things like that. And as part of my role currently at Intel, what I do is I help large enterprises to adopt generative AI. They might have a lot of generative AI use cases, and they come to us at Intel, and we help them to optimize those AI solutions on Intel hardware. So Intel is a hardware company, right? So we manufacture all the CPUs, GPUs, accelerators, and things like that. All your laptops might be running on Intel Core 2 Duo or Intel processors. So all these are manufactured, and we'll also today see how those chips are manufactured and how each chip differs. How do you differentiate chips, right? How do you differentiate a CPU, GPU, and things like that? So three things we'll discuss. We'll briefly discuss about generative AI and challenges and opportunities, and finally Q&A, and with a short demo. If time permits, I'll show a short demo. So what is AI, right? Generally, if you most of you might be knowing at least basic programming, right? With the basic programming is like you give some data to a computer, and you also do a programming, and the computer gives you an output. This is a traditional programming, right? But if AI, classical AI, not the generative AI, if you take classical AI ML, what it does is, instead of giving data plus program, you give data plus past output, whatever past output you had. You give that to the computer, and the computer gives out a program. Program is, or the model, it gives out a model which is a set of rules and regulations on how to generate an output. That's a kind of a differentiation between traditional programming versus AI, right? Classical AI ML. Now, if you ask me what are the different layers of AI, like AI is there, artificial intelligence is a very big umbrella. Within that, there's a classical AI ML. I think most of you would have been exposed to some kind of an AI ML. Maybe there might be like, say, Alexa, Siri, or maybe some some of your fridges or air conditioning or some of your home appliances might have some kind of an AI in it, right? Those are all mostly falls under machine learning or kind of this area of things. More advanced than machine learning is something called deep learning, where neural networks are something that mimics human brains, like how human brains thinks. Human brain is not programmed, right? You are given a situation and you respond to the situation based on how the condition, based on how you know about the past instance like that. So based on that, the deep learning uses similar artificial neurons to decipher what is happening, and that's what deep learning is. And more the advanced evolution of deep learning is what generative AI, that's what we are going to talk about today. So I think one thing that I want to make clear is today we have a lot of equipments like a television, LG TV with AI, maybe a refrigerator with AI, even your coffee machine with AI. Is it all really an AI, right? Do you think the AI that gets advertised on the TV or your coffee machine, is it really an AI, right? And AI should be like, if I ask a coffee machine, if I go near a coffee machine, if it automatically tells, today you look very excited and happy, let me prepare an espresso for you, right? Then that will be an AI enabled coffee machine, right? But that's not a traditional, whatever machines that you see today is not kind of equipped with that kind of an AI. So we cannot really term all these equipments that are generally labeled with AI as AI enabled. They are just programs. They have certain rules and regulations. You tap on this button, this rule will be executed and this output you will get. So they are not actually AI. Actual AI will be when it can actually sense what's happening in its environment and respond to that. So now let's come to generative AI, right? Generative AI is something that we are going to talk today extensively. So like I said in the very beginning of the statement, generative AI can be your very best friend or it can be your worst enemy. Why is that? It's not a statement that I made casually. That is because generative AI, all this time, whatever AI we had, it never bothered all the skilled workers. You and me are kind of fall into the category of skilled workers because we are skilled in certain technologies and we are expert in that. And so probably AI was not a competition for us in all this time. But nowadays with generative AI can learn a lot of things. It can become an expert in a particular subject and it can generate brand new content. Today we'll see as part of the demo how it can generate a lot of new content. It can be a new competition for us. And you might be thinking, I'm from an electrical background, so let me not bother about this generative AI, let me sleep or let me talk to my colleague like how those students are talking there, right? Let me talk and let me not give enough attention to this topic. So if you do that, what will happen is eventually 5 years or 10 years down the line, probably this generative AI is going to take over a lot of our skilled workers, including electrical department or electronics, chemistry, biology and all those things. I'll tell you how it is. So let's first define what is generative AI. Generative AI is a brand new branch of AI that can generate brand new content that never existed earlier, right? So I think everybody is, how many of you have not used ChatGPT? Anyone here not used ChatGPT? All of you have used ChatGPT? Can I ask the ChatGPT URL? Can I pick one person and ask you the ChatGPT URL? Will you be able to tell me the URL for the ChatGPT? All of you have used? Can you tell me what's the URL for ChatGPT? The guy who is smiling in the fourth. Yeah, you. I'll pick random person, so please be attentive. Do you know the URL? Have you used ChatGPT?
Yes, sir. Use it, sir.
Okay, why do you use ChatGPT?
Research work.
Like, can you tell me one question that you posted to ChatGPT?
Tree climbing robot.
Okay. So when you posted this question, tree climbing robot, like how do I design a tree climbing robot?
Yes,
did it give you the perfect answer to that, or it was where you 100% happy with the answer that you got from ChatGPT?
No, sir.
Okay. So this question comes, right? So now you might be under assumption that I posted a question, I want to design a tree climbing robot. And it gave you some answer, maybe it was 50 or 60% correct answer.
Yes, sir.
Yeah, right? But you were not happy and you might be thinking, okay, this is just another tool which will help me. But how do I improvise that? So there's a technique called fine tuning. Let's say you are working exclusively on robotics. So you have exclusively a lot of books and documentation on robotics. You can feed all those exclusive data onto this particular model, like the ChatGPT model, and make ChatGPT an expert in robotics. Currently, ChatGPT is not an expert in specific domain. It's an expert in it knows everything, bits and pieces of everything, right? Yes. It knows everything from 3500 BC till to 2020. Whatever data is there, open source, openly available data is there. It knows everything from 3500 BC till 2020, whatever is there. But it doesn't know specific questions to your data related to tree climbing robot. So what you can do is to assist you in assist you in your research. You can take all your books. Maybe you might have books that are running thousands of pages. Scan those. If you have the PDF versions of those books, you can take that book and feed that data into the model. Now the the AI model becomes intelligent in that specific domain. And now if you ask same question to that model, what is the how do I design an tree climbing robot? It will give you better answer by referring to those books, right? Thank you, please sit down. So what I'm saying is generative AI can be your best friend. If you are going to utilize generative AI, you need to know certain techniques. You cannot rely only on ChatGPT or openly available things. There are certain things where you can actually fine tune those models to your specific domain. Say I am going to work on autonomous electrical vehicles. So I cannot use only ChatGPT for that. I need to enable ChatGPT to be more specific expert on autonomous electrical vehicles. That I can do it by a process called fine tuning. So maybe in future sessions we'll show you how you can do fine tuning. We'll have a series of sessions like this where you can do keep learning more advanced topics in generative AI. Yeah, so I'll give you a brief history of how ChatGPT came and what are the things, right? ChatGPT is probably the birth can be attributed in mid of 2017 when Google came up with an algorithm called transformers algorithm. So that's when the original ChatGPT or the birth of ChatGPT happened. And there is a concept called parameters. So how do you measure the power of a particular AI model is there's a concept called parameter. The initial parameter that was developed in mid of 2017 was 65 million. It had 65 million parameters, and it was able to fairly give a little bit of fairly good answers. And slowly as things progressed, as years progressed, the number of parameters kept on increasing. By 2019, we had ChatGPT GPT-2. It was private. Still 2019, it was private, and it had around 1.5 billion parameter. And when ChatGPT 3, that was what was publicly released in mid of 2020, it had 175 billion parameters. So 175 billion parameters when it was released in 2020, it had almost all the data from 3500 BC till mid of 2020, whatever data, publicly available data, right? It had that in that 175 billion parameter. And slowly now today, if you are going to ChatGPT, it is using a model called GPT-4, which is having parameters more than 1 trillion parameters. So that means the amount of data it can hold, the amount of complexity it has is tremendously increased, and it keeps increasing every year new models keeps coming. This is from ChatGPT, but there are Facebook has its own model called Llama, and Microsoft has its own model called Phi-2 and others. So others keeps coming, right? So what's happening here is as years progresses, the models keeps increasing, and the amount of compute power that is required, right? Just to give you an idea, this ChatGPT 3 to train this model, they took 16,000 GPUs. 16,000 GPUs running continuously 24/7 for 6 months to train this model. That's the amount of compute power that is required to get this model, right? Then you can imagine, you can extrapolate, and you can imagine how much amount of GPU power and how much amount of compute power was required to train this 1 trillion parameter model. So huge amount of compute power is definitely required when you're dealing with generative AI. I'll give you an example how much amount of memory, RAM, right? Everybody knows RAM, right? The computer hardware RAM, right? So just to load a 7 billion parameter, here I'm taking up a open source model called Llama, and that has around 7 billion parameters. It's a 7 billion parameter, not even a 1 trillion. ChatGPT is 1 trillion parameter. I'm just taking a 7 billion parameter model and trying to load it into memory. Just load. I'm not doing anything. I'm not doing any execution, not doing anything, right? Just to load it requires around 67 GB of memory. This is a very small model. 7 billion parameter model is a very small model, and it requires 67 GB of memory. That means when you are dealing with generative AI, you need huge amount of compute power, and it's not always feasible for everyone to acquire those kind of hardware, right? It's very expensive. Just to give you one idea, Intel has a accelerator for AI called Gaudi accelerator, and that one machine alone costs 160,000 US dollars. The 160,000 US dollars comes to around almost 1 crore 10 lakhs or 20 lakhs, something like that. So one machine costs, and like that you have to use, like they use 16,000 machines, right? You need to use that kind of money is required. So not everybody is able to create a new model, right? So what you have to do is you have to use open source models that are currently available, like the Llama model that was available. And once you use open source model, you can actually build models that are very specific to a specific domain. Like the person said, he wanted to build for manufacturing. Maybe he wanted to build a robot for manufacturing sector. So you can build models that are very specific, that are very intelligent in a specific domain. Like it can be manufacturing, teleco, automotive, retail, finance, health, or education. Even in education itself, Generative AI is going to be revolutionize a lot of things, right? So let's say we are dealing with electrical engineering. We can take all the books on electrical engineering and train the Generative AI model, and then connect it to a voice agent. And now it will become your virtual teacher, which is available 24/7, right? And it can answer all the questions related to electrical engineering accurately because it is trained in that electrical engineering things. So education is one sector that is going to be heavily impacted with Generative AI. So I said about ChatGPT, right? Like ChatGPT was there, it was not giving you perfect answers for that question. So there are two ways you can actually inject data into an existing model. You can inject the model using a process called fine tuning. Let's say you have lot of historical data, huge amounts of historical data, and you want to inject that historical data into a model. Then you can use a process called fine tuning. But if you have small amounts of real-time data, let's say you want to predict stocks, stock price, or you want your model to know even the latest invention. Let's say yesterday there was a new type of electrical component invented, and you want your model to know about that. Then you can use a process called retrieval augmented generation. So all these terms you don't have to know in depth for now. Just remember these terms. In future series of sessions, we'll go in depth of each of these terms and try to explain you how you can do fine tuning, how you can do retrieval augmented generations, right? So there are two ways you can do this fine tuning and retrieval augmented generation. One is you can take up ChatGPT and implement fine tuning and retrieval augmented generation. Or you can use open source models from Facebook, right? Facebook has an open source model called Llama 2, Llama 3. You can take up those models and implement fine tuning and RAG or retrieval augmented generation, and then generate models that are specific to specific industry. Like for him it was a robotics. For others it might be like, say he might be working in a defense sector. He might be working on some missiles or something. So you might want to build models that are very intelligent on those specific things. Now, what are the different types of hardware available for you to run your Generative AI models? The very basic model that is available, very basic processor that is available is called AI PC. I think most of you are aware of Intel Core series of processor, right? So there is a brand new processor from Intel just was released some 6 months back. It called Intel Core Ultra, right? So Intel Core Ultra is also called as EIPC. It's a processor which has CPU in it. Also has a new type of compute element called neural processing unit. Along with CPU, it also has neural processing unit. And you can use that if you have a model of 1 billion parameter model, you can use it to do an inferencing right on your laptop. Or if you have up to 20 billion parameter, you can do it on a Xeon processor. Or processors that are server grade processor. It cannot be generally used for your normal laptop or desktop. It's mostly used for servers. And if you have up to 100 billion parameters, you can use multiple GPUs or multiple CPUs. And it goes on like that. I mean, if you want more than 100 billion parameter model, you need to have an entire data center. Like you might have to want to use 16,000 GPUs to do a training of 100 billion plus parameter models.
This incredible.
Okay. before I show this video, right? So this video is all about a machine that is used to write the circuits on your silicon. Everybody knows that, right? CPUs or all the integrated circuits are basically silicon based. You take a silicon die and then you fabricate that circuits, electrical circuits on that. How do you do that? There's a machine called machine from a company called ASML. ASML is the only company in the world who manufactures this machine. So Intel, TSMC, Samsung, all these providers have to go to this company called ASML to acquire this machine. And this particular machine, the video that I'm going to show you, it's a machine that uses extreme ultraviolet light to write silicon transistors that are 1.8 nanometers. That is 1.8 nanometers is almost close to you're getting to one atom per transistor, right? That's the level of complexity that you're going. And it's a very extremely complicated engineering to generate, to manufacture this machine. And you can they'll explain it, and then we can see if we have any questions, we can go on that.
This incredible machine is as big as a double-decker bus and weighs about as much as a blue whale. To get it from ASML's headquarters in the Netherlands to Intel's Gordon Moore Park in Oregon took more than 250 crates in 43 freight containers loaded in multiple cargo planes and 20 semi-trucks. This new transistor-making tool will forever change the chip industry. It's the world's first high numerical aperture extreme ultraviolet lithography system, also known as High-NA EUV. It is likely the most complicated manufacturing tool humans have ever built, and it's the result of 30-plus years of collaboration between Intel, ASML, and its ecosystem of suppliers.
And so seeing that finally arrive at the dock and having seen over the years the drawings, the animations, how exactly we would ship these components and handle them, and seeing it all come together was pretty neat.
Lithography machines like ASML's High-NA EXE 5000 project circuit patterns onto hundreds of individual chips on a silicon wafer. The more transistors and components crammed onto each chip, the more capable that chip becomes. The essence of Moore's law is to deliver this innovation at roughly the same cost every 2 technology nodes, starting with Intel 14A. This tool is so massive it occupies 3 floors in a fab. Its laser is strong enough to cut steel. A beam transport transmits the laser pulse into the High-NA machine, where it slams into tiny droplets of molten tin. Each hot metal droplet only about 1/3 the diameter of a human hair. When that powerful laser, flashing at 50,000 times a second, hits the molten tin, the metal vaporizes into a plasma. This plasma releases light in the extreme ultraviolet range. A collector mirror gathers the EUV light and shoots it to a scanner where it pinballs off extremely precise mirrors that shape the light into a slit that can transfer the patterns of transistors and interconnects. A reticle hosts those patterns and transfers that information through projection optics at a data rate comparable to over 100 movies per second. The projection optics are the key technology that enables High-NA.
The largest mirror is the flattest surface ever devised by man. If you stretched that mirror across the entire surface of the planet, the thickness variation would be less than a playing card.
The High-NA tool will require more than 1,000 electrical and mechanical connections. It will shoot lasers at light speed and heat plasma to nearly 220,000 degrees Celsius, almost 40 times hotter than the surface temperature of the sun.
It's amazing to see how complicated the design is and how amazing it is to see it come to life.
Shrinking transistors to atomic size is one of humanity's greatest technology feats. High-NA will help Intel Foundry deliver never-seen-before precision and scalability in chip manufacturing.
So you saw how complicated that machine is, and there are so many high-end technologies that goes into manufacturing this machine, right? Just to generate that extreme ultraviolet UV, you saw that you need to actually melt tin in real time in tiny droplets and flash that tin with the plasma lights to generate that extreme ultraviolet UV lights, right? In precision, it has to be generated in a precision that is mapping with your electrical circuits, the electrical circuit design that you have. In that pattern, it has to be generated and then burned. It will go and burn the silicon to create that transistors. Now I'll slightly get into CPUs. Everybody knows CPUs, right? So generally CPUs have a lot of cores and it will do a lot of operations. But when you go into an advanced CPUs like the Xeon CPUs for servers, it not only has the normal traditional cores, it also has additional specific circuits called accelerators that are meant to do specific jobs. Let's say if you take this, this is the breakup of Intel 4th Gen Xeon processor. Along with the traditional, it has around 46 cores. So along with the traditional cores, it also has a lot of accelerators. One of the accelerators that I'm specifically interested in is called AMX, or Advanced Matrix Extension. So this accelerator, what it does is it's very good in doing matrix multiplication. I think many of you are learning about in your engineering course matrix multiplication and things like that, and you might be wondering, why am I being bothered with this matrix multiplication? All these matrix multiplications will be extensively be used specifically in generative AI and traditional AI, right? How do you use that, right? I'll give you an example. Now, if I ask you, I'll tell you Vignan, what is the next word you are going to tell me? You, the lady, first lady, you. I'll tell you Vignan. You only. Yeah. I'll tell just Vignan. Tell me what is the next word after Vignan.
Deem it to be university.
Okay. Can you tell me what is the next word if I tell Vignan? What can be, other than deemed to be university is what she told. What can be the other word? Yeah, science and technology. Okay. So two people gave two different answers, right? Now, if you ask ChatGPT, if you have the same questions, it can also have the same kind of thinking. So this person gave deemed to be an university. She gave an answer as Vignan Science and Technology for Research, right? So she gave a different answer. What it does is, it will scan. Let's assume that you gave a bunch of documents, and it will see how many times Vignan deemed to be an university is there, and it will see how many times Vignan Science and Technology Foundation, the word is there. And it will give a ranking. Based on that ranking, it will generate a matrix, right? On one row, it will have all the words, another one it will be ranking. Ranking is, let's say, deemed to be university is the word that occurs 100 times. And VFSTR comes 50 times. So VFSTR will be given rank 2, and deemed to be university will be given rank 1. And this is one parameter that I'm telling you. The model can take up a lot more other factors, right? It might see how many times that word is important, how important that word is next word to be, right? Model doesn't know what is Vignan University or what is Vignan deemed to be university. It doesn't know the actual meaning. It only knows how many times these words are coming. So it will actually build up a matrix with rows and columns, and gives, it will be multi-dimensional. It's not a two-dimensional with rows and columns. It will have X, Y, and Z. And all those matrix multiplication, you have to do complex matrix multiplication. Just to generate the very next word, it might have to do some trillions of matrix multiplication. And all those matrix multiplication will run on these accelerators. And one of the reasons why GPUs are preferred in AI is, GPUs are very good in doing matrix multiplications. CPUs can do matrix multiplication, but they are not efficient in doing matrix multiplication. But GPUs are very good in doing matrix multiplication. And that's why you see a lot of people telling that if I are dealing with AI, you want to use GPUs. And Intel saw that we have this industry moving towards a lot of AI. So what it did was, it took the CPU, it added an accelerator called AMX, Advanced Matrix Extension, so that all your matrix multiplications can be done on those things, so that it can efficiently run on your CPU itself. So if you are using AI, majority of your workloads will be running on that AMX accelerators to fasten up your calculations so that you get the output more easily. Just to give you one example, right? If you are using traditional core, here I think Modin is, I'll tell you what this graph is. So Modin is an open source Python library. So if you are having a large Excel sheet or a CSV file with a lot of data, let's say you have a student name, student roll number, department and rank and subjects like this, right? And you want to parse that Excel file. And if you are using Modin, right? Modin is an open source library to parse that Excel file. If you are using traditional cores, and let's assume that the file size is almost 2.4 gigabyte. The file size is 2.4 gigabyte. And if you are running it with traditional cores, it almost took 340 seconds to run it on an Intel Xeon, second generation Intel Xeon, right? Now, I'll do small modification in my code to make it run using accelerators also. So then what will happen is the time reduced from 340 seconds, it will drop down to 31 seconds. So when you instruct your program to use accelerators along with your CPU, traditional CPU cores, you see suddenly your code performs extremely well, like 10x improvement. Instead of taking 340 seconds to process a 2.4 gigabyte file, it's going to take around 31 seconds. So learn that the modern CPUs not only has traditional cores, it also has accelerators. You as an engineer probably might have to learn how to use those accelerators as well. Now I'll briefly talk about the Intel Core Ultra that I told you, right? So Intel Core Ultra is in brand new processor that was released around 8 months back, and it has traditional CPUs that you are all aware, like you know the CPU cores. It also has GPU right integrated into the same silicon. There's one silicon which has CPU, GPU, and a new type of compute element called neural processing unit. And neural processing unit again does matrix multiplication more efficiently than CPU or GPU, right? So all these three compute elements come in one silicon. So if you are upgrading your laptop, you want to decide if you see that Intel Core Ultra, go for it, because it has more compute elements than the traditional Intel Core series of processor, and it will give you better performance for all your AI workloads. So this is an example of showing how when you have a frame, like video, and you want to see how the inferencing of that video happens, like how much time it takes on NPU, CPU and GPU. Basically NPU will be in between, the performance of NPU will be between CPU and GPU. GPU definitely will give you a better performance. NPU is like in between CPU and GPU. So challenges with generative AI, right? So one of the biggest challenges is generative AI is the beginning of synthetic evolution, right? All this time we are all organic creatures, and we have been evolving over the years, millions of years, right? Now this advent of new kind of synthetic AI intelligence is coming up. And it's going to be a boon or threat based on how we try to utilize it, right? Because some experts say that generative AI could pose an existential threat to humanity. The kind of research that are happening with generative AI is so advanced that it can actually outpace humans, and sometimes maybe in future, if it gets into a wrong hands, it can actually control human beings. That's the kind of threat it has. Then it can also lead to a lot of misinformation and disinformation, right? Generative AI can generate brand new content. It can generate a brand new video. If I have my photos, I can take some 10 or 20 pictures of mine, and I can train a model, and I can generate brand new videos, brand new photos of me with that doesn't exist. And using that, it can actually do a lot of misinformation or disinformation campaigns can be done. Or deepfakes. Deepfakes, I think probably many of you are aware, a lot of deepfake videos are coming up. It's good in one sense if you are using it in a good area. Like if you want to be creative, you can use that. But many people are misusing it to create harm to others. And then data privacy and job displacement is something that is of a real concern. Today, as we speak, many of our customers are actually developing tools that can write code. So if machines can write the code by themselves, then my software engineering job is at stake, right? Instead of people hiring an expert, like I have 20 years of experience, and if somebody asks me to write an algorithm to quick sort, I might take, let's say I might take 30 minutes to write a quicksort algorithm. The same question you pose to an generative AI model, It can give you the answer in 2 seconds, and the answer that it gives might be better than the answer that I'll be giving after 30 minutes, right? So it will be all these generative AI models going to be a threat, especially for skilled workers like you and me. Even like say you are all electrical engineers, you will have a lot of knowledge on electrical engineering or electronics engineering. And now if I have to design a brand new CPU or brand new circuit, instead of relying on experienced person, I can go to a generative AI model and tell, give me this answer. It will give you the answer in 2 seconds. It will give you an almost 90% accurate answer in 2 seconds. And you spend 1 or 2 days in refining that idea, and you have a product. So the need for an skilled worker will be a challenge, right? So earlier, if you see, before the beginning of industrial revolution, there was a difference between man and human. So man had traditionally had muscle power. So man used to go outside and work, and traditionally women used to be within the confines of home and doing all the household work. And with the advent of machines and industrial revolution, what happened was the muscle power was invalidated. Like muscle power was no more relevant. So both man and woman can work in the industry, can go out and do that. And then now there's a skill gap. I'm a 20 years experienced guy. You're just going to start your career. So you're zero years experience. So there's a difference between you and me, right? My 20 years of experience, I have a lot of knowledge. You're just beginning your career. So what is the difference now? This difference is going to be bridged by generative AI. Now, if you ask me, like he said he wanted to build a tree climbing robot, right? And he doesn't have complete knowledge on that tree climbing robot. He'll go to ChatGPT and will ask it. It will give you the answer immediately. So the gap between a skilled worker of 20 years and a zero experienced guy is going to be bridged by this generative AI. So that gap is going to be bridged. Now there is no more difference between an experienced person and a fresher. So that can be both an advantage and a disadvantage. It will be an advantage if you know how to use these tools. You need to know how to use better. Whoever knows how to use these tools better will be able to survive in the future. 5 years down the line, you will see a lot of skilled workers, skilled jobs going to be automated or to be greatly be assisted by generative AI. Like skilled workers, when I'm telling it's not only coding or engineering, it can be even filmmaking, right? In the filmmaking, there's a skilled worker required to generate a music, to sing a song, to create that visualization, to create that direction, to even generate as a script, right? Today you can go to ChatGPT and tell, generate me a film script and give the storyline, like it can be a love story or it can be crime thriller or whatever that you want to describe it, and within 5 seconds it will give the entire film script. Take that film script and give to another model called models like Imagen from Google. You can give that to that model. It can generate that entire video for you, including the actors. Like the actors, if you want the actor to be Rajnikant or NTR or anybody of your favorite stars, take their actors' photos, train that model, and it will use that script and generate the video for you, right? Now you don't need the real musician, you don't need real script writers, you don't need real actors. Everything is done by machines. All you have to do is sit, relax in this chair, watch the movie, and you can enjoy your life, right? But then jobs of all those skilled people will be at stake. Loss of human touch, that's where if you see the challenges, loss of human touch. When all these things are being manually done by machines, the human touch, the human emotions, everything might be lost. If you don't feed those emotions and things like that into the generative AI model, those things will be lost eventually. We are at least fortunate, we are all, at least you and me are all fortunate to see this transition where lot of things were happening manually and now it's all going to be automated. So we are happy to see that transition happening. But maybe that the next generation, 10 years down the line, kids who are born after 10 years, they'll be seeing only automated things. So they don't see that human touch in those in the things that the skilled workers are doing, right? All those things will be lost. From an opportunities perspective, content creation, like I said, generate high quality content such as images, videos, music, text for various industry like media, entertainment and marketing. This is one which is going to be, I think everybody is already using. I am a big fan of ChatGPT, trying to use for, if I want to wish somebody, I'll write a message, I'll describe qualities of that person in brief, and he'll write a poem, nice poem in 5 seconds, and a very good poem. You'll be also be happy. I am also happy that my workload is, I don't have to put my head too much. He'll also happy. It gives you very good content. And art and design is one, probably I'll show you an example of art and design. Drug discovery. Drug discovery is an extensive area where generative AI is being used to discover new drugs. Like they take a open source model and then fine tune that model with all the drug discovery information and then create new drugs fastly. If it was earlier taking 1 year to invent a new drug, probably in weeks you can generate new drugs. Then scientific research, definitely it accelerates a lot of scientific research. Any questions? If you don't ask me a question, I'll pick you. I think people in the last are all silently avoiding. We can catch up somebody from the last. Can you give mic to one person in the last, sir? Give the mic to any one person that you like. Like or dislike. Questions? I think this is the time you can get the time to ask questions to actual humans. Maybe 2-3 years down the line, you can ask only questions to your machines. So utilize that opportunity. We will go to the demo, I think, then. Feel free to ask the questions if you have any. Using ChatGPT. ChatGPT is, you give a text prompt to it, it will spit out text. That is a model, like it's a singular model. Text is the input, text is the output. But there is also a model called Stable Diffusion. It's an open source model. And this model, you give a text to it, it will give an image as an output, right? So here, so hopefully you can read this text that I'm trying to give. I'm giving the text as an abstract sculpture of a white marble colored head and neck in slight profile with the skin made up of intricate patterns with mechanical gears and mechanical elements with a serene garden in the background, giving it an organic yet technological appearance. So I've given a very good prompt here. One thing that you have to note here is I have used a lot of adjectives. When you're actually dealing with generative AI, if you use a lot of adjectives like serene, colorful, white, photorealism, intricate, realistic, it tries to give you better output. So now let's see, I gave you this output and try to see what is the image it generates. So how this stable diffusion model works is it will start with a very noisy image. It takes up this noisy image and slowly it will iterate. It will take this text, it will convert this text into a mathematical representation, vector representation, and slightly try to understand what is the command that you gave. And basically it's all about matrix multiplication that is happening, and slightly it is trying to generate that image for you. Let's see what is the final image. I have given steps. There's a one of the parameters is called steps. So basically I think I have given 15 steps as the thing. So it will iterate through that command 15 times to generate that final image. I have given the steps as 30. So it's going to iterate through 30 times from that noisy image to generate the final image for you. See, you can see each step how it is improving from one step to another. If you reduce the number of steps, probably the accuracy will go down. See, from noisy image it came to here. Let's see from at the end of 30 steps what is the output. And this feature is already available on your WhatsApp also. For those of you who don't know, in WhatsApp there is a new icon, blue color icon. It's an icon for generative AI. It can generate both text and images for you. So tomorrow if you want to generate a birthday card or any images or a birthday message, you can use your WhatsApp. You can give this kind of a prompt in your WhatsApp to generate that image. So slowly it's generating. Probably it's not very accurate to the description that I gave. But definitely you can see it's improving with every iterations. Meanwhile, while it is generating, you can see a lot of example images that I had generated earlier with the different prompts. There's a birthday cake and things like that I had generated. This particular Okay, let this finish and then I'll give this prompt. How many of you are fans of Sunrise Hyderabad team? Any fans here? One, only one fan. Two fan. Being in Andhra, you're not a fan of Sunrise Hyderabad. Maybe it's because in Telangana. Has Sunrise Hyderabad won any IPL Cup? I'm not aware. Has it? Okay, this is the image it generated, but let me try to generate another image. This time the prompt that I gave was hyper-realistic Virat Kohli with the RCB team t-shirt receiving the IPL trophy at Paris with Eiffel Tower in the background. High quality 8K. RCB team is not being able to win any IPL cup. At least we'll be, let's see if Generative AI can give the cup to it. Let's see if it's generating Virat Kohli holding the cup. Or you want Pat Cummins is the captain, right, for Hyderabad, Sunrise Hyderabad. We can try it out with Pat Cummins as well. Oh, we have so many Virat Kohlis. At least in Generative AI, we are able to win the cup. Anybody wants to try out any prompt? So you can see, right, all this is running on a single Xeon processor machine, right? If we have like thousands of Xeon processor machines or GPUs or something like that, you can give your entire film script. You can go to ChatGPT and ask it to generate the film script, give the script here, it will generate the entire movie for you. And we can train that model. That model now knows all these popular figures like Virat Kohli and other things. But you want, let's say you want to be the hero in that movie and you want your popular heroine, right? You can take that, or vice versa. You are a popular, you want to be the heroine and you want your popular hero to be there. You can train that model with your face and give the script and have a movie, complete movie for you, right? So this is how all this Generative AI is going to largely influence in next sessions that we plan to do. We might have lots of hands-on session. The seats will be limited. People who are really interested can nominate themselves for those things. We can have an hands-on session where you will actually write the code to do all these things. Right now it's all tools that are there. But since you and me are engineers, we need to know the internal details of how things work. So let's generate those things for ourselves. I think with that we can conclude for today's session unless we have any questions. So please use Generative AI as much as possible. Don't be Generative AI. You don't have to be lazy now. Learn Generative AI now, so that rest of your life you can be lazy. So that Generative AI does all your work. You can sit and relax. If you are lazy now, rest of your life you will have to work. So decide whether you want to be lazy for 3 years or lazy for your entire life. So with that I'll conclude. Thanks everyone.
Feedback on these sections. 2 sessions. How many of you learned some delta x? Some delta x. Or at least introduction? Raise your hand. Introduction. So good done.
What should I learn? So students, right? So if you all have to become a Generative AI engineer, experts in Generative AI, first thing is you should have passion, like interest to learn. Once you have interest to learn, Generative AI itself, you can begin with WhatsApp's Generative AI or ChatGPT to begin with, or you can attend sessions like this. We're going to have even more sessions in the future where we'll have a hands-on workshop where we'll teach you from the basics Python coding first. It's a very basic minimum that requirement is required. And then we'll learn a lot of libraries like PyTorch and others where you can actually tweak all these Generative AI frameworks and understand the internal details. You don't have to be an end user. You should, as an engineer, you should know what are the internal details of a Generative AI model so that you can tweak around to make it work for you. Make whatever work you want to do, right? Whatever the things that you want to do, let it do, and you can sit and relax while it does the work. So we will have a series of workshops. That's what we are planning to have. And let's hopefully if you are passionate enough and you go back, you do further research. Now you know bits and pieces. This was a very basic introduction that we gave. We touched upon a lot of things. We touched upon the hardware, software, and use cases, opportunities, and threats. So at least you know some basic idea now. Go back, do further research, further explore what are the different things available, and that keep that excitement going, and that way you can keep start learning new things, right? Thank you.
And one more thing is, we want to thank from the management side, since you are interested in conducting many other session too. As you know that there are a lot of technology is increasing. Already madam told you she is interested in cloud technologies. Anish told you he is interested in conducting the Gen AI. So come out of from your regular, what can we say, regular idleness. So be active. Now it is time to go at a faster moment. Technology cannot wait for you. People who are aware with the technology, they are having place on this earth. So that's the point. Everyone of us, not you, every one of us has to understand. Otherwise, we won't have the place on this. Technology is moving forward in such a way that people who knows the technology, they are having the place in the running marathons. We don't have the place. So we should be move like as fast as possible. So be thorough with your regular academics on one stream, and in the other stream, now when you entered into the second year itself, you have to decide where should you go with a lot of passion and interest. Thank you, sir, motivating all of us with your good things. Thank you so much.